Ada ya?
Especially for the video, Zaina.
Okay, we'll check it again.
Okay.
A huge number of luminescent lamps is manufactured worldwide. They require safe utilization. Sergei Trebukov's technology allows to considerably enhance mercury extraction.
Yeah. The audio also on.
Okay. How about links? Check.
Okay, clear?
Если у вас проблемы с перхотью, если шелушится кожа или она чрезмерно жирная, если страдаете аллергией, если вас измучило пониженное артериальное давление, если в общем слабая иммунная система, значит вашему организму необходим селен, не металл серого цвета.
Link is okay?
Yes, also clear.
Okay, thank you very much. Normal. Normal.
Titr çok değil mi?
Neredesin ki kalma?
Senin hoşun mu?
Zaten öğrettiğin seçiliyorsun.
Демонстрация нажимается пока что.
Траверсин казбасы. Или хаижный.
Траверс. Правильно. Что, полный инфраголосный?
Я полный инфраголосный.
А?
Я.
Сам даже утром свет? Когда будем разговаривать, они же утром свет?
Я, собственно.
Казбасы söyle полный.
Я сюда
Мен тұрып кетем,
я
я нан жайлап бүйтіп өзімізге қарап
қалдырып бұрып алып істе.
мына жерін жауып алсай, мойның жаман болып тұр.
Вот так? Қысып тұр мені.
Я олар не любит она, мой машина.
Олардың бәрі.
Мұсылман.
Қысатынан былай жақсы.
Надо было вчера сказать. Мы поделись вот так.
А, они не любят.
Да, у них это самое, не привык.
Ну ладно.
Ну енді.
Бірақ сендер мұсылман емессің.
Былай жалынбайды.
Жоқ, ол жабылды береді.
Мойында болды.
Мойында.
Қысат, тамағын так.
Мынандай тамағын себетін бар ма?
Жоқ.
Жыбырлап кетсем не істейміз?
Мына жерге су әкеліп.
Не деген бар? Имен деме, не деген?
Микрофон что это? Пока что.
Микрофон выключен.
Короче, қазір қайдам дейсің? Міне тұр ғой. Төмен түсіп. Тұра берсін, не істейсің? Тұра берсін. Не істейсің? Светті неге жақпады?
Анау арқаға жаман болып көрініп өткен.
Нормально. Нормально.
Маскамен отырамыз ба? Маскамен? Или через
Разговаривать.
Мен маскасы отырам.
Даусың тут приглушаться, да?
Мешайте туду.
Когда презентация принесла на флешке зеленой, я ее не сдавала.
Біздер кірді ме?
Международный экспедиция. Біздің лаборатория кірді және кіргісі кетті.
Отыр үстіне.
А,
Здесь они не будут просто такие задавать.
А если вдруг?
болмады.
Возможно, ашпырны. Сен болсаң, оннан объектке кетті.
Сөйлеп отыр ғой.
Есімін
Сөйлеген жоқ қой.
Ана сөйлеп отыр.
Қазір ана сөйлестіңіздер ғой, естіліп тұр ғой.
Звук қайда?
Қосылып тұр, суықтар.
Қосылып тұр да? Болды. Ашып қоя ғой. Болды.
Hello, Professor. Hello.
Hello.
So the preparation is okay?
Yes.
Okay, Professor.
Өзі адамдар келмей.
We are waiting for Professor Shahril, our editor-in-chief, to join with us. Maybe he will join in a few minutes. Is it okay, Professor? We are waiting for the Professor Shahril.
Oke.
Oh, okay. Halo, Assalamualaikum, Pak Syahril.
Hello.
Assalamualaikum, Pak Syahril. Alah. Halo, Assalamualaikum, Pak Syahril.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Now, our editor-in-chief, also vice of the rector, Professor Shahril, is with us now, but maybe there is some problem in his audio. Assalamualaikum, Prof. Shahril. Halo, Profesor Shahril. Ada masalah, Pak? Dengan audionya, Pak? Masih unmute, Pak, suara Bapak. Masih mute.
Oke.
Oke, alhamdulillahirrahmanirrahim. Kita mulai sekarang atau nunggu berapa menit lagi, Pak? Ini masih 72 orang, 73.
Ya. Silakan, Ki.
Oke, mungkin sebagian live di YouTube. Oke, Pak, kita mulai, Pak. Professor Bagdaulet, can we start now?
Yes.
Because some of the participants live in the YouTube. Okay, we can start now. Assalamualaikum warahmatullahi wabarakatuh. May I have your attention, please, the audience? We will start our symposium in shortly, and please mute your microphone to avoid the interruption during the presentation. Good day, Assalamualaikum warahmatullahi wabarakatuh. Your Excellencies, Rector of Universitas Negeri Padang, Dean of Faculty of Engineering, Dr. Fahmi Rizal, Head of Department of Mechanical Engineering, Mr. Purwantono. Head of Research Institute and Community Service, Mr. Yohandri, PhD. Editor-in-Chief, Professor Shahril, and the Honorable Speaker, Doctor of the Technical Science, Professor Bagdaulet Kenzhaliyev, lecturers from various universities in Indonesia and across the nation, fellow students, ladies and gentlemen. It is my pleasure to be an MC and your moderator for the symposium organized by Teknomekanik Journal, Department of Mechanical Engineering, Faculty of Engineering, Universitas Negeri Padang. I am Sri Rizky Putri Primandari, PhD. You can call me Kiki. On behalf of Teknomekanik Journal and the committees, I would like to welcome you to this symposium. We are appreciate you in joining us today. To opening this symposium, we welcome Professor Shahril, PhD, Editor-in-Chief of Teknomekanik Journal, to deliver the opening speech. Professor Shahril, please,
Hello.
time is yours.
Yes. Thank you,
Professor.
Kiki. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Waalaikumsalam warahmatullahi wabarakatuh.
The Honorable of Rector Universitas Negeri Padang, Prof. Ganepri, PhD, Dean Faculty of Engineering, Dr. Fahmi Rizal, Head of Material Engineering Department, Mr. Purwantono, with all lecturer, staff, and committee. A special one, today our speaker is Professor Bagdaulet Kenzhaliyev. Yeah, from Satbayev University, Republic of Kazakhstan. Thank you, Prof, for your knowledge sharing. Ladies and gentlemen, first to all, let us thank to Allah Subhanahu wa Ta'ala who has given us His blessing so that today we can see Ozer virtual here to join this event. I given my big thank you from and appreciation to the committee who have working hard and hold this symposium. This event is the 4th international symposium which is presented by Teknomekanik Journal, organized by Department of Mechanical Engineering, Faculty of Engineering, sponsored by Research Center, Universitas Negeri Padang. For information, it's an international journal which is dedicated to the improvement and disseminate of the knowledge, method, policies, technologies, and technical science and vocational education. It will come contribution from all who wish to report a new development and latest finding in engineering, new trend and progress, provide practice in the listed file, and creating a unique form, for interdisciplinary and multidisciplinary knowledge. Teknomekanik Journal published 2 issues a year, and it has been indexed by Sinta, Google Scholar, Garuda, and Dimension. So far, everyone who has qualified article with these areas, please send to Mechanic Journal for publication. Ladies and gentlemen, this symposium will have an outstanding speaker from Satbayev University, Republic of Kazakhstan, Professor Bagdaulet Kenzhaliyev. Very sorry. will present his paper in detail, develop and implementation of innovative technology, providing increasing extraction of non-ferrous, noble, rare and rare earth metals, and solution of reaction tests of industrial enterprise of Republic of Kazakhstan. The paper contain update knowledge, so we can get new input and new understanding from it. So everyone, please follow this symposium well and take a good advantage of the question and answer session. Last, I am as editor-in-chief of Teknomekanik Journal. Once more, would like to welcome you all to this international symposium, and we wish this event will be benefit everybody. Now, I officially open this symposium by saying Bismillahirrahmanirrahim. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Alhamdulillah. Thank you, sir, for opening this symposium officially. For your information, the audience and also Prof. Bagdaulet, our journal, Teknomekanik Journal, is under Indonesia government accreditation, and now we are under Scopus accreditation, road to Scopus accreditation. Okay, ladies and gentlemen, next is presentation from Professor Bagdaulet. I will share the Professor Bagdaulet. Next presentation from our speaker. During the presentation, the audience are welcome. Deliver the question in the chat column, and after presentation, I will read your question, or you can deliver the question directly. Before our honorable speaker present his article, let me introduce him to you. Can you see my screen, the audience? Professor, can you see? Professor Bagdaulet, can you see my screen clearly?
Yes.
Yeah, thank you very much. I will introduce Professor to you all. Doctor of Technical Science, Professor Bagdaulet Kenzhaliyev, is the General Director of Institute of Metallurgy and Ore Beneficiation, Satbayev University, Almaty, Republic of Kazakhstan. He has won many prestigious awards, such as laureate of Al-Farabi State Prize of the Republic of Kazakhstan in 2019, which is the highest recognition of the merits of science and technology for society and the state. Honored Worker of the Republic of Kazakhstan, laureate of Lenin Komsomol Prize of Kazakhstan in 1981 in the field of the science and technology, winner of the 2 bronze medals of the USSR Exhibition of Economic Achievement and Debate for merit in the development science of the Republic of Kazakhstan. In 1975, he graduated from SM Kirov Kazakh State University. He studied chemical engineering science, majoring in teaching chemistry. Bagdaulet Kenzhaliyev is an author of over 500 scientific publications, including in a foreign publication, 7 monographs, over 88 patents and copyright certificate of the Republic of Kazakhstan, Russian Federation, USA, and Germany. Please welcome our speaker, Professor Bagdaulet, to present his topic on development and implementation of innovative technologies that ensure an increase in the extraction of non-ferrous, noble, rare earth metals, and the solution of the production problems of industrial enterprises of the Republic of Kazakhstan. Please, Professor, time is yours.
Thank you.
You're
Hello.
welcome.
Hello, dear ladies
Hello? Professor? Zaina? Is there any problem in your connection? Hello? Hello, Professor?
Symposium.
Okay. Just now there is interruption from your connection, Professor. Connection lost. Hello? Okay, Professor. Is there any problem, Professor?
Yes, yes.
Never mind. Taking your time, Professor.
интернет жоғалып кетіп жатыр. Бастай беріңіз.
Okay,
Today
I
I would
can
like
clearly.
to speak about the development of innovative technologies providing an increase in the extraction of non-ferrous, noble, rare, and rare earth metals. Institute of Metallurgy and Verification was established in 1945 in Almaty. It is an ex-capital city of Kazakhstan. Today, Institute has become the largest research center in the Republic of Kazakhstan. During the period of the Institute's activity, the physical-chemical foundations for the beneficiation and extraction from ores and concentrates of heavy non-ferrous, light, rare, and noble metals have been created. Fundamentally new technological schemes and equipment have been developed and introduced at a number of domestic and foreign enterprises. At present, the most important problem of the metallurgical industry is the development and implementation of innovative technologies, enabling to extract with maximum completeness of non-ferrous, rare, and rare earth metals contained in ores, industrial goods, and secondary raw materials. The next slide shows one of the technologies developed by our staff of the Institute for Extracting Mercury. Let us watch a video for about 2 minutes.
A huge number of luminescent lamps is manufactured worldwide. They require safe utilization. Sergei Trebukov's technology allows to considerably enhance mercury extraction from scrap lamps.
Sorry, Professor, your slide screen is not moved.
Vacuum installation
It's
works.
in the slide 1, the first slide.
Sorry.
Hello?
Yes.
Yeah. Still in the first slide.
We are still in first slide.
Yeah, still in the first slide.
Бірінші слайд.
Запускасанда дұрыстап жасамады дедіңіз.
Бірінші слайд көрмей қалды ма?
Бірінші слайдта тұрсындар дейді.
А сейчас?
And now, how about now?
Now, yeah, first slide, second slide.
Okay. Thank you.
How about the video?
Yes.
Zaina?
Yes.
A huge number of
Can you see the
Is it okay
video?
now?
Okay.
Is it okay now?
A huge number of luminescent lamps is manufactured worldwide. They require safe utilization. Sergei Trebukov's technology allows to considerably enhance mercury extraction from scrap lamps. Compared to similar designs, the vibration vacuum installation works continuously, increasing its capacity 14 times. The cost of utilizing one lamp is twice as low as based on competing technologies. The growing global trend of using energy-efficient light sources built with metallic mercury as luminescence catalyst provokes the need for their environmentally safe utilization. The challenge is relevant not only for Kazakhstan but likewise for many developed countries of the world. The project aims to address the issue of exploiting the most ecologically safe vacuum method. The technology is based on extracting mercury in vibration vacuum chambers. Lamp glass fragments are loaded into chamber, where by means of vibration, low pressure and high temperature, they are completely stripped of luminescent compound. Glass calcine accumulates in the bottom section. Process gases are collected via special nozzle, whereas mercury-containing gases accumulating in the upper section of the chamber are channeled to collector cooling tanks via pipe system. Mercury stripping rate is up to 99.9%. Process gases and calcine constitute no environmental hazard. The process does not require any chemical reagents and the installation works non-stop, reducing heat losses to minimum. The technology allows significant energy and cost saving, utilization of other mercury-containing objects and processing of fossil raw materials are also possible. An industrial unit with a capacity of 1.5 million scrap luminescent lamps will be launched in Astana, the new city FAZ, in the nearest future.
Institute has 8 research laboratories and one national research and physical analytical laboratory with modern analytical equipment from leading world brands that allows you to quickly perform analysis of any complexity. We have also a pilot experimental metallurgical plant. Now let's have a look at video. It gives more information about our research activities.
Сам селен не встречается в чистом виде, только в форме каких-либо соединений. Институт металлургии и обогащения Satbayev University разработал технологию по выпуску чистого селена, чему нет отечественных аналогов.
В настоящее время вам представлено уникальное оборудование, вакуум-дистилляционная установка для рафинирования чернового селена. Производительность оборудования составляет до 100 килограмм в сутки, то есть это 2 тонны в месяц. При этом на выходе получается рафинированный селен соответствующей марки СТ-0 по ГОСТ 10, межгосударственный стандарт 10298 с содержанием более 99,5% основного компонента. Технология ориентирована на реализацию на Балхашском деплавильном заводе ТО корпорации «Казахмыс». Сейчас между институтом и Балхашским деплавильным заводом подписан договор на научно-технологическое сопровождение данного проекта.
За мной создана установка, которая будет внедрена на Балхашской площадке. В данный момент производится строительство, подготовка рабочей площадки к установке данной технологии, и она будет реализована в конце этого года.
В конечном продукте объемное содержание селена составляет 99,8%. Это позволяет исключить необходимость дополнительной сложной обработки сырья. Данный тип селена получил широкое распространение при производстве химической и стекольной продукции. Ему нет равных в фармакологическом секторе. На этом у меня все. Надеюсь, что выпуск был максимально полезным и интересным. До новых встреч!
In the last time, Institute has developed innovative and modern technologies for the extraction of metals from technogenic and low quality metal containing raw materials. They are implemented in the industry in Kazakhstan. These works are timed to increase production parameters and improve the ecological parameters of non-ferrous metallurgy industry. Now, my doctoral students will continue the present ready to be implemented projects in the industry.
Thank you very much, Professor Bagdaulet Kenzhaliyev. Good day, dear colleagues. My name is Maral Subekova. I am a third-year PhD student in Satbayev University. And today we would like to note the most significant works performed in the Institute of Metallurgy and Ore Beneficiation. And the first one is synthesis technology of a new forming agent for the intensification of flotation concentration of gold-bearing ores. It's well known that currently depletion of primary ores of various metals all over the world faces with such problems like involvement into the process refractory, difficult, and off-balance ores. One of the ways to solve this problem could be preliminary preparation of these refractory ores for metallurgical processing, so-called beneficiation process. And our institute developed technology for producing this forming agent. It is environmentally friendly forming agent produced from alcohol production wastes, from fusel oils. And the main advantages of this fuming agents is that it is very cheap, and at the same time it has a good selectivity. It's non-toxic, has pleasant smell, and number of experiments were done in the institute, and the obtained concentrates had gold content of 38 grams per ton. It means that extraction of gold into the concentrate was 88.8%. And the gold recovery was increased by 4.67%. And the content of gold in flotation tailings also decreased from 0.4 to 0.3 grams per tons. And also, I would like to highlight that this new forming agent increased the extraction of gold into the concentrate by 3–4%, and the consumption of the reagent decreased by 20% in comparison with other existing traditional forming agents. However, the complete extraction of valuable components from refractory ores is a very difficult process, and it is possible to achieve this extraction satisfactorily only when you combine, for example, two methods using of domestic composite reagents and the multi-component microflotation method that can be performed with a turboflotation apparatus. And the introduction of the proposed multi-component microflotation technology at the mining and metallurgical enterprises will significantly increase the extraction of valuable components, and at the same time it increased the competitiveness of the products in the world market, take a leading position in the promotion of innovative technologies both within the country and abroad. And this developed technology for flotation concentration of refractory gold-bearing ores using water-air microemulsion generator improves the floatability of sludge particles, and also it increased gold recovery by 4–5%. On this slide, you can see the table which presents the comparison of flotation parameters using the normal mode and water-air microemulsion generator. And as you can see, the bubble sizes in VAM generator is much more smaller. It's approximately from 20 to 50 micrometers. Flotation time decreased by 25–30%, and loss of valuable components also decreased by 15–20%. The payback of such technology will be 6–8 months. Okay. Next technology, I would like to introduce the technology for gold recovering from refractory gold-bearing ores. This flotation concentration technology is a leaching process for gravity and flotation concentrates in the presence of oxidizer in order to open the gold. And the results of the stage flotation of this concentration showed that it is possible to obtain gold tailings, flotation tailings, with the gold grade less than 0.7 grams per ton. And extraction of gold into the concentrate will be 88.88%. It means that this concentrate will contain 49.7 grams per ton of gold. And also the number of pilot tests were carried out with ores from Siksovskaya deposit that has gold content approximately 6.04 grams per ton. And when we obtained the gold-bearing concentrate, the extraction of this of gold into this concentrate was 80.6%, and the gold content in it was 58.3 grams per ton. After that, these gravitational concentrates was subjected into two processes. The first is using modified oxidant, and the second is in the basic mode with air supply. And after sorption cyanidation of this gravity concentrate in the basic mode, we found out that gold transferred to the solution in amount of 87%. And in the second case, when we used modified oxidizer, calcium hypochlorite, the gold extraction into solution was 88.5%. That means that it's 1.5% higher than in the basic mode. And the novelty of this work lies in the preliminary oxidation of sulfide minerals during the leaching of gold-bearing raw materials using a new modified oxidizing, which is a mixture of calcium hypochlorite and trichloroisocyanuric acid in the proportion 3:1. Okay. Next. The next slide shows the technology of contractile pyrometallurgical selection of persistent gold-bearing raw materials. Currently, there are no technology that can process refractory gold ores containing such kind of impurities like arsenic, sulfur, carbon, and other volatile components. And that's why our institute developed such technology in order to provide the direct smelting of refractory gold-bearing ores, in order to transfer all impurities like arsenic, sulfur, and carbon into the gas phase. After that, this gas phase will be neutralized, and but all precious and non-ferrous metals will concentrate in the matte melt. And the total volume of this matte melt will be approximately 10–15% of the charge weight. And the extraction of these precious metals into the matte would be as follows. For gold, it would be 95–98%, for silver 85–90%, and for copper also 85–90%. After that, this matte can be processed in copper smelters using any existing technology. And the extraction of noble metals is 20–30% higher in this technology in comparison with technologies that used in industry. And the main condition for the efficiency of the process is that gold content should be not less than 5 grams per ton. And now I would like to show you a short presentation that presented technology of pyrometallurgical processing of refractory gold-bearing ores.
Металлургия обогащения является крупным научно-исследовательским центром мирового уровня, осуществляющим разработку инновационных технологий в области обогащения минерального сырья, металлургии и материаловедения. Разработана технология переработки упорных золотосодержащих руд. Технология включает предварительную подготовку руды и флюсов, заключающуюся в дроблении до крупности не более 25 мм и сушки до остаточного содержания влаги в 6%, которая производится в сушильных барабанах. Далее шихта направляется на плавку в электропечи с добавлением восстановителя, с получением штейна, отвального шлака и отходящих газов с пылями. Грубая пыль из газов отделяется в системе грубой пылеочистки, состоящей из пылевой камеры и циклонов. Полученный штейновый расплав разливается в изложницы и направляется на дальнейшую переработку. Технология защищена охранными документами Республики Казахстан. Металлургия и обогащение является крупным научным...
Okay, thank you for watching. Next technology that I would like to introduce you, it's metallurgical slag processing technology in a furnace with a coke filter. The existing method of depletion of non-ferrous metallurgical slags do not provide a sufficiently complete extraction of metals from slag, and that's why this technology was developed. It is technology for liquid metallurgical slags in a furnace with electrically heated coke oven filters that helps to obtain a metallized phase that concentrates iron, copper, and other precious metals, and also fumes containing lead and zinc. Slags completely dumping for non-ferrous metals that further can be used for production of building materials. And the heating of the coke filter is performed in the electrical furnace with electric energy that helps significantly reduce the consumption of coke, which is here used as a reagent, and to obtain a minimum amount of waste gases with a significant reduction in the cost of cleaning them. The copper extraction into an iron copper alloy will be 91.9%, extraction of iron will be 70%, and lead and zinc into sublimates will be 94 and 88% respectively. And also average coke consumption is 5-7% in the processed slag mass. This technology is recommended for use in non-ferrous metallurgy enterprises. Here on this slide, you can see the technology for continuous conversion technology of copper mats in the Vanyukov furnace. The main disadvantage of the world's most widespread technology intended to process copper mats in Pearce-Smith converters, it is its periodicity. And also at the same time, it's difficult to use gases that are not constant in terms of the silicon dioxide content. And this technology, continuous conversion technology of copper mats in the Vanyukov furnace, makes it possible to obtain gases of constant composition, which will be rich in sulfur dioxide, that further can be used in the production of sulfuric acid. And also it makes it possible to obtain blister copper and a minimum volume of copper poor converter slags. The using of this technology eliminates the periodicity of the blister copper production process, and also allow to use the oxygen enriched blast to obtain a stable flow of sour gas, which will help to which contributes to an improvement in the environmental situation. Also on this slide, you can see the main parameters of the continuous mat converting furnace. Its productivity on mats will be from 55 to 65 tons per hour, and copper content in the mats that we will obtain will be from 55 to 60%. And this technology is recommended for use in non-ferrous metallurgical enterprises with a copper mat conversion process. Okay, thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, dear guests. My name is Abika Kirkijan, and I am second year doctoral student. And now I would like to tell about technology of selenium extraction with its subsequent refining. Kazakhstan annually produces more than 70 tons of raw selenium, which is sold abroad, where it is refined and used in the semiconductor industry. In the process of obtaining copper, sludge of copper electrolyte and sulfuric acid production containing selenium is formed. We have developed technologies for extracting elemental selenium from this industrial product with subsequent refining by vacuum distillation. Copper electrolyte production slimes containing selenium are formed in the process to obtain copper. We have developed technologies to extract elemental selenium from this middling product with subsequent refining. An industrial prototype of vacuum distillation unit was made with a capacity of 2 tons. As a result, brand selenium was obtained containing 99.8% of the main component that is demanded in all world metal markets. The technology is environmentally friendly, cost-effective, and has a number of know-how elements. At present, the largest smelting plants in Kazakhstan and Russia have been shown interest in the technology. Now I would like to tell about technology of processing ferrous sands of alumina production. The increased iron content in bauxite results in serious sintering problem. Therefore, it is required to preliminarily separate ferruginous compounds as much as possible. Iron sands from the bauxite bulk. The processing of ferruginous sands is an important practical task, the solution of which will increase the profitability of the existing alumina production at the Pavlodar aluminum plant. The technology developed the processing ferruginous sands includes the production of cast iron, concentrates or rare metals, rare earth elements, red and black pigments, and titanium dioxide. Concentrates of rare metals, gallium and vanadium of the composition will be by the weight mass, aluminium oxide 30, gallium oxide 0.32, and vanadium pentoxide approximately 5. This concentration were obtained from the aluminate leaching solution. As a result of the reduction melting of the ferrous sand leaching cake at the temperature about 145 degrees, cast iron and unmetallic slag were obtained. Also, the iron oil in the cast iron was approximately 99.4%. A concentrate containing of rare earth metal was approximately 21%. In this slide, you can see the technological scheme of the technology of processing ferrous sands. It will be start first with firing, then the leaching. After leaching, we have 2 stages to magnetic separation. We have non-magnetic fraction and magnetic fraction. For the obtaining cast iron and slag, we use this magnetic fraction. Now, the next technology is obtaining rare and rare earth metals from industrial products and waste of terrachrome production. Their importance to solve the problem of use the products of chromium ore dressing in waste processing is associated not only with the environment, but also with the need to increase the chromium production. The enterprise engaged in the extraction and beneficiation of chromium raw materials in Kazakhstan is situated in Donskoy mining processing plant. During the operation of the concentrating factories, the plant had stockpiled about 15 million tons of sludge tailing. The loss of chromium oxide by the beneficiation technology was approximately 25.5%. The known methods of utilization of terrachrome production middlings and waste products don't enable to extract accompanying valuable components, rare metals and rare earth metals along the way. A technological scheme for the complex processing of chromium wastes has been developed, including leaching the ammonium hydrosulfide obtained to concentrate of rare metals, gallium and vanadium, a concentrate of rare earth elements with a content about 22%, and chromium concentrate with the content of 59.1%. Technological regulations and preliminary business plan for the planned production have been also developed. Technological regulation of the production project for the production of concentrates of rare and rare earth metals from industrial products and waste on Kazkhrom with a capacity of 200,000 tons per year, and preliminary business plan will determine the main technical and economic indicators of production efficiency. The payback period of this project is approximately 5 years. The implementation recommendations indicate that in order to increase profitability, it is necessary to provide for the possibility of obtaining commodity products of increased value, gallium metal, vanadium pentoxide, selective rare earth metals, and amorphous silica. Also on this slide, you can see the final products upon received chrome concentrate with the name of this product. Next one is technology of extraction of rare earth metals from extraction phosphoric acid obtained by processing phosphorates. Purpose of this work is to develop a technology for extracting rare earth metals from extraction phosphoric acid in order to obtain a concentrate of rare earth metals using sorption methods, which will increase the profitability of the existing production at the mineral fertilizer plant in Taraz city of Kazakhstan. A technology has been developed for the extraction of rare earth metals from extraction phosphoric acid. Technological modes of desorption for rare earth metals from a cation exchanger to obtain concentrate of rare earth metals have been worked out. Various desorbing solutions have been tested. There are ammonium chloride, ammonium sulfate, a mixture of nitric acid with ammonium nitrate, a mixture of hydrochloric acid with the ammonium chloride, a mixture of sulfuric acid with ammonium sulfide. The optimal conditions for the desorption of rare earth metals from the Purosorb 104 cation exchanger have been determined. The precipitation parameters of rare earth metals have been determined and conditioned. Approximately 93% of concentrate of rare earth metals was obtained. Also on this slide, you can see the material balance of extraction of rare earth metals from extraction phosphoric acid. Now, on the slide, you can see the technology of obtaining concentrates of rare earth metals from industrial products of alumina production. When bauxites are processed in Kazakhstan, along with alumina, only gallium is extracted in the amount approximately 8% of the receipt. Other rare metals included in their composition are of industrial interest, but their behavior in the processes of alumina production has not been sufficiently studied. Based on the studies of the work, the existing alumina processing plant of high iron bauxite, aluminium of Kazakhstan, industrial products containing rare metals, recycled soda, слайд убрался. Отключился слайд.
Заявка на тендер подается вот так. Это телевизор объявляет Карагандинский университет, выделяет 350 тысяч за единицу, 11 штук на общую сумму 3 миллиона 800 тысяч. Мы нашли этот телевизор в Китае на Алибабе, $389. Это пример.
Sorry, we have some problems. Let me continue. Based on studies on the work of the existing aluminium processing plant of high iron bauxite, aluminium of Kazakhstan, industrial products containing rare metals, recycled soda, ferrous sands, and red sludge were selected, and technological scheme for their joint processing was developed to obtain a collective concentrate with a content of gallium approximately 0.4%, and for vanadium pentoxide approximately 15%. According to ammonia technology, vanadium pentoxide with content of 99.1% was obtained. To obtain metallic gallium, a method of electrolysis on the rotating galated cathode has been developed. The recovery during electrolysis was 95.9% with an electricity consumption approximately 88 per kilogram of value. A technical and economic calculation of the production of rare metals from industrial products of alumina production was carried out and technological regulation were developed. Also, you can see the technological scheme for the obtaining concentrates of rare metals from industrial products. Now, I would like to tell about Bayer hydrogranate technology of waste-free processing of pyrogenous cocktail bauxite. A gradual decrease in the high-quality bauxite production, high operating cost, and energy intensity of this method use the extraction and processing of raw materials, in combination with their environmentally unfavorable impact. Alumina production in the Republic of Kazakhstan, with the help of Bayer sintering technology, become less profitable and competitive and requires some modernization. The developed Bayer hydrogranate technology enables to solve the problem of high iron, low quality bauxite processing with minimization of alkali and alumina losses. Also, there will be reduction of electricity consumption and also material costs. The technology includes the red mud processing. You can see on this technological scheme. It will include the red mud processing from the Bayer branch using the hydrogranate technology and conversion of aluminate solution to obtain aluminum hydroxide. The use of hydrogranate processing made it possible to extract in additional approximately 11% of aluminium. The possibility to obtain cast iron from hydrogranate sludge by means of reduction melting at temperature 1650 degrees has been determined. The peak iron yield was approximately 40% of the weight of the initial charge. Now, I would like to show for you the video about this scheme.
Институтом металлургии и обогащения была инициирована программа разработка Bayer гидрогранатовой технологии переработки железистых бокситов, получившая одобрение в правительстве Республики Казахстан. В качестве надежной сырьевой базы определены бокситы коктальской группы месторождения. Ресурсы месторождения составляют более 300 миллионов тонн, что позволяет обеспечивать работу завода мощностью 1 миллион тонн в год на период более 100 лет. В результате исследований казахстанских ученых разработана безотходная Bayer гидрогранатовая технология переработки коктальских бокситов, обеспечивающая высокие технологические и экономические показатели. Это снижение капитальных затрат на строительство завода, экономия расхода, удельных норм реагентов, уменьшение затрат на условное топливо, значительное снижение в 3 раза вредных экологических выбросов, получение наряду с металлургическим глиноземом также чугуна, цемента и редких металлов, полная утилизация золы заводской ТЭЦ с получением глинозема и силикатной продукции. Института металлургии.
Thank you for attention. Also, our institute engaged in the processing of pyrid cinder, development of technology for processing pyrid cinder with the extraction of valuable components and preliminary chemical activation of raw materials. Pyrid cinder are a valuable source of ferrous, non-ferrous, and precious metals unused to date due to the lack of economically viable technologies. The pyrometallurgical methods of processing these technogenic raw materials introduced at a number of enterprises are based on chlorinating roasting and chlorine distillation. They have a number of disadvantages. They are a poisonous component it used for opening, chlorine, and are suitable for processing raw materials of a certain composition. And in this project, we developed physico-chemical studies of representative sample of technogenic raw materials. Also, the granulometric composition was investigated and the concentration of noble and non-ferrous metal was determined. As a result of magnetic separation, we have two fractions, magnetic fraction and non-magnetic fraction. Magnetic class with minus 2.5 millimeter, non-magnetic with plus 2.5 millimeter. Also, mineralogical analysis was carried out in combination with scanning electron microscopy and X-ray spectral microanalysis. And for the finding optimal parameters of these technologies, we used mathematical modeling with using 4 parameters. There are temperature, ratio of liquid to solid, concentration of bicarbonate solution, and the time. After construction of mathematical modeling and studying, we found the optimum parameters is temperature 120 degree, duration between 30 and 60 minutes, and ratio of liquid to solid is 4:1, and concentration of bicarbonate solution is 60 gram per decimeter, which is the maximum change in phase and chemical composition also were obtained. And after finding the optimal parameters, we made leaching under optimal condition, leaching with the sulfuric acid, extraction into solution. We have the copper oxide, zinc oxide, and iron oxide. On this slide, you can see the percentages also. Without chemical activation, the degree of extraction was lower, approximately 20%. As a result of stage-by-stage neutralization of the leaching solution at pH 9.7, a precipitated concentrated of non-ferrous metals by weight was obtained also. Our technological scheme for the with the preliminary activation of the pirate cinder includes magnetic separation with the divided non-magnetic fraction and magnetic fraction. After that, we have preliminary chemical activation with bicarbonate solution, and we have leaching in sulfuric acid solution. Also, we have two-stage neutralization with the release at pH 9.7, a precipitate concentrate of non-ferrous metals, copper and zinc, and reducing melting of the leaching cake with the addition of calcium oxide to obtain high-grade cast iron. Also, you can see the copper cast iron when we have obtained from our pirate cinder. Thank you.
Thank you very much, Maral and Erkejan. Next slide. Is about a number of projects with foreign companies. Suez company works on the separation of zinc from the collective concentrated of heavy non-ferrous metals. The company and not energy works to implement the project assessment of local raw metals in Oman for the production of ceramic profantas. The company Almaty mining and metallurgical plant is to improve the process of smelting copper sulfide concentrates in liquid baths in Uzbekistan. The company aluminum project is to conduct pilot tests of the processing technology in Russia. Dear ladies and gentlemen, thank you very much for your attention.
Okay, Alhamdulillah. Thank you very much, Professor, for the amazing article, presentation, and also your amazing research and your study in your institute. Now, audience, we open the question and answer session. You can raise your hand. Okay, I see one participant raise the hand. Rini Lisbeth Sitio. Hello? Rini Lisbeth Sitio. Are you there? Or anyone can raise the hands to deliver the question directly to the professor, or unmute your microphone to deliver the question directly. Anyone? Please. Okay. If there is no one to deliver directly, I will read the question that's sent by us during the presentation. Okay, Professor. First question is, what is the obstacles and the challenge in the rare urbanification? What is the challenge and the problem maybe in urbanification or leaching process, especially in your institute?
Yes, thank you very much, Dr. Kiki.
Welcome.
Проблемалар қандай қиындықтар бар дейді. Металлды алып алуда.
Қиындық жоқ. Қиындық жоқ. Себебі бізде квалифицированный ғалымдар жұмыс істейді.
Actually, there is no challenges because we have qualified staff and personals for extracting metals.
Is there all of the equipment or the instrument is in your institute, Professor?
Лабораториялар бәрі бар ма?
Yeah.
Оборудование бәрі бар, толық оборудование.
We have also modern equipment in our laboratory because every year, according to the project and implementation of this project, we buy new equipment, and we also have modernization for this, and in that way we don't have a lot of problem, but sometimes to solve the problem we need a time to have certain works.
Oh, it's great. So there is any one institute or under the government except your university in urbanification? Or you have the collaboration with the industry?
Осы институттан басқа институт организациялар университеттер бар ма дейді. Коллаборация бар ма деп.
Since your equipment is very complete and modern.
Модернизированная лаборатория аналитическая. Осы институт, национальная лаборатория бар.
In we have collaboration with national laboratories in the Republic of Kazakhstan, and it helps to be modern. It helps to do a lot of works with collaboration of these national laboratories, which will support of Ministry of Education and Science of Kazakhstan.
Including the analysis, the instrument of the analysis?
Yeah.
Yes, also analysis. Yeah. We have analytical laboratories, which includes
and physical laboratory.
Analytical and physical laboratory.
Technology laboratory.
They include in a national laboratory.
Oh, it's great. And also, since most of your research or your study assisted by the chemical treatment. Is it right, Professor? As I seen in your presentation, most of them assisted by the chemical treatment.
Yes. Ғылыми жұмыстар жасалған кезде ше. Ғылыми жұмыстар жасайсыздар ғой, эксперимент жасайсыздар ғой, сөзді химический лаборатория.
How about the physical
Yes, chemical analytical laboratory. Yes. Oh.
We use not only chemical treatment, but also physical treatment.
Oh yeah,
in
physical
our-
treatment. What kind of the
yes.
physical treatment that you
Mechanical laboratory.
applied?
X-ray phase analysis, mineralogical analysis, and also X-ray fluorescent analysis and other mechanical analysis also is used.
yes.
What is it?
All this information you can find on our site, imio.
Okay. How about the ultrasound or ultrasonic system? Have you ever tried to apply in your leaching process?
Ultrasистема
Ultrasound.
Yes, of course, we also use it.
Oh, you should use it. How about it? Is it economic to use in industry? If we applied in industry, such as the ultrasound, and also I see electrolysis. Yeah.
Қолдану экономикалық жағынан.
How
far do you use?
Внедрен. Да. Производство внедрен.
Экономикалық жағынан тиімді ма деп сұрап жатыр.
Внедрен производство.
Can you repeat the question
Много
about
технологий внедрен производство.
Dr. Kiki? Can you repeat the question about economic profitable? Yeah, you say.
Yeah, maybe it can be see in the economic and also in the what we call practicing. More practice in between we use the chemical and the physical treatment.
When we have some research work, our first step is to make it easy. We have pilot studies, and after economic counting, after some researching, we have a solution to is it profitable or not, and that way. In that way, to implement in the industry or in the government. Before this, we have pilot implementation or pilot research. No, I don't know how to say it. And after this researching, we have implementation in industry, and that's why it's also economic profitable.
Okay. How about the comparison between the mechanical and the physical treatment? Have you ever compared the result of two methods? Yeah.
Алған кезде
Have you ever compared between the chemical and physical treatment? Which one is have the good result? Yeah. The better result.
We're saying the results of chemical and physical analysis are almost the same, and that's why we use both of them.
Стандартное сравнивание со стандартом.
Yes, it doesn't differ from each other in much.
Стандартный материал, не сравнивать.
Because it impact to the waste, is that right? Impact to the waste. If you use the chemical treatment, it means it produce waste chemical. Have you ever how to manage the chemical waste from the extraction or the leaching process?
металлды алған кезде шыққан отход.
Yeah, we want to learn more about the waste treatment in the chemical waste.
Стараемся разработать безотходную технологию. Конец, вот сегодня тоже кирпич для силикатной продукции, для пигмента, он использует. Ну, сейчас требования экологии жесткие, как в мире, и так и в Казахстане. Поэтому мы разрабатываем технологию, стараемся быть безотходной технологией.
We are trying to use the recycled process. In that way, we don't have any waste, and we also our waste is used for the liquid glasses, for the pigment, black and red pigments, how I say in my presentation. And our technological schemes and processes are recycled. In that way, we don't have any waste.
Also, it means zero waste treatment.
Yeah.
It's great. We'll move to next question I get from the chat column. What are the technique or ways to ensure increased extraction of non-ferrous, precious, rare earth metals? And what can the metal extraction can be used for at this time?
Какие технологии используются для повышения?
What technique or ways to ensure increased extraction? Maybe the best technique in ore beneficiation. From Mr. Johnny Aritonang. He asks about the best method or technique in ore beneficiation.
Енді ол
From
технология
your study, Professor.
қазір сырьенің ішіндегі металлдардың содержаниясы және оның құрамы өте сложный. Сондықтан применяется специальная технология с учетом базового химического и минералогического состава.
Now our ores to extract non-ferrous, precious, or another metals have difficult composition. To solve this problem, we have a lot of technologies. The last technologies that we can use for the best extraction to these metals is preliminary activation.
Oh, preliminary activation with using the chemical just presented in your article. Okay, Mr.
Не только активация.
Is there any follow-up answer?
Используются специальные реагенты, специальные композиционные материалы для того, чтобы извлечь, на примере золота. Золото в основном сегодня в мире теряется тонкодисперсным продуктах, и мы его раскрываем. Поэтому сейчас эта наша технология заинтересована не только в Казахстане, но и за рубежом.
We use preliminary activation also, for example, for the extraction of gold. The extraction of gold is the best technologies in our country, and to open the gold ore, we use some reagents, some chemical reagents.
Сейчас вот то, что докладывал я, некоторые технологии, которые мы собираемся внедрять и за рубежом. И переработка отходов в Швейцарии, вот бытовых отходов, оттуда цветные металлы получаем. Или получение меди из трудноперерабатываемых руд в Узбекистане, тоже уже внедрение идет. Или в России сейчас специально испытываем для получения пигменты, комплексы использования безотходной технологии. То есть они к нам обращаются, чтобы мы разработали, из-за того, что здесь работают квалифицированные ученые.
Professor says that not only in Kazakhstan we have implementation our research work, but on the abroad, for example, in Uzbekistan, we have some work with, in Uzbekistan, in Turkey and Russia. We have new projects to extract metals, and after approving of this project, it will be implemented in these countries. In Switzerland, we have new projects about waste.
цинк и другие металлы из этого.
Which company works on the separation of zinc from the collective concentrate of heavy non-ferrous metals? It means we will extract heavy non-ferrous metals from West in Swiss company.
Okay, thank you very much for the explanation. Bapak Ibu sekalian boleh mengajukan pertanyaan, bisa juga di dalam bahasa Indonesia. Nanti saya akan menerjemahkannya ke dalam bahasa Inggris. Dipersilakan kepada Bapak Ibu. Oh ya, Pak Waskito. Oh ya, for your information, Professor Bagdaulet, now we have Dr. Waskito, our Vice Dean in Faculty Engineering in Academic Affair. Pak Waskito, ada pertanyaan Pak Waskito? We have Mr. Waskito, Dr. Waskito, our Vice Dean, Faculty of Engineering. Pak Waskito masih mute, Pak. Halo, Pak Waskito?
Yes.
Oke.
Okay. Thank you, Mr. Sri Rizky and Professor from Kazakhstan University. I want to asking about. Hello, are you hear me, Mr. Professor?
Yeah,
Okay.
yeah, Pak Waskito, we can hear you
Yes.
clearly.
Yeah.
But you, Professor Bagdaulet, can you hear the Dr. Waskito's voice?
Yeah.
Yeah.
Okay, continue, sir.
Yes.
Okay, thank you. I continue. I want to know about the processing the material. Why the processing result material without was free from the material. Thank you.
Can you please repeat the question?
Okay.
Bisa diulang lagi pertanyaannya, Pak?
Yes, I want to know why the processing about the material result the was free material. Boleh dengan bahasa Indonesia nanti.
Boleh Pak.
Ya, saya ingin tahu sebenarnya bagaimana proses yang substansi prosesnya, mengapa proses ini bisa menghasilkan material yang begitu murni, tidak menghasilkan limbah sedikit pun. Terima kasih.
Okay, thank you very much for the question, sir. So, Professor, Dr. Waskito asking about how to, what is the essential or the concept of the ore beneficiation to produce the pure element or pure ore. Is it clear, Professor Bagdaulet? The concept of the essential process, concept to produce the pure material.
Металдарды алған кезде ше, таза металды алғанның қандай концепциясы бар деп сұрапты.
Несі?
Концепциясы қандай? Таза металдарды алу үшін қандай концепция қолданасыздар?
Is it the leaching process?
Получение.
Это выщелачивание, говорит, основное.
Нет, не только. Это зависит от содержания металлов в исходной сырье или концентрате. То есть подход такой, если концентрат позволяет получить высокотемпературным методом, или может оказаться она невыгодна, поэтому гидрометаллургический метод могут применяться.
For example, for the finding the concept to extract pure metal. Yeah, first of all, we should take the sample, the initial sample, and make an analysis, and we should see the composition of the metal that we will extract in initial sample. After that, we will decide how it will be better to extract pure metal.
We use both hydrometallurgy and pyrometallurgy to make extraction.
Это зависит от состава, от содержания и экономическая выгодность учитывается при этом.
It depends on the composition of initial sample, and it will depend also of economical profitable of this process.
Сначала проводится поисковые исследования. По поисковым исследованиям уже можно анализировать пирометаллургический или гидрометаллургический метод, или через обогащение идти.
First of all, also we have literature review, and we should decide what stage or what way will be better, pyrometallurgical process or hydrometallurgical process for the extract of pure metal.
Concentrate.
Okay. Thank you very much, Professor, for the answer. Jadi, Pak Waskito, mereka itu teknik yang digunakan itu tergantung dari karakteristik dari sampel yang akan diekstrak. Jadi, contohnya mereka mengambil sampel dulu, kemudian mereka akan menganalisis sampel tersebut dan mencari tahu apa saja komposisi di dalam sampel yang akan diekstrak. Hal ini menentukan teknologi atau metode yang akan digunakan, karena ada beberapa, karena mereka harus mengklasifikasi mana yang oxidized, logam yang mudah teroksidasi, ada yang logam yang tidak mudah teroksidasi. Jadi ini akan menentukan proses yang akan mereka pilih di dalam pemurnian biji tadi ya, biji logam yang akan dimurnikan tersebut. Bisa melalui chemical tadi kan Pak ya, bisa melalui teknik kimia atau mulai menggunakan bahan-bahan kimia yang seperti yang sudah dipresentasikan, ataupun bisa menggunakan physical. Kalau seandainya fisik untuk yang non radioaktif ataupun non yang tidak teroksidasi. Kalau yang mudah teroksidasi itu mungkin mereka akan menggunakan chemical composition untuk agennya. Ada pertanyaan lagi Pak Waskito? Is it clear? Or there is any follow-up question? Ya Pak, masih mute Pak.
Masih oke.
Iya masih.
Okay. Thank you very much for your information, Professor and team. Make me more understanding from the processing for pure material. Thank you very much.
Okay, thank you very much. We have another question from Mr. Johnny Aritonang. Maybe you can give an example of the chemical reaction from raw materials so that it become a pure new metal elements. I think this question is already answered before. Or you please to re-answer or explain for this question, Professor and the team.
Мысалы, былай, алтынның содержаниясы 1 грамм, 2 грамм тоннада болуы мүмкін. Оны тек қана гидрометаллургиялық методпен ғана алынады. Гидрометаллургия. Оны растворға шығарады, әуелі выщелачивать етіп, раствордан сорбция жасайды, концентрировать етіп, сорбциядан десорбция жасайды, сосын электролиз, металл дария получает, металл дарияны апинажға апарып, плавить етіп, уже 99% золото получает. Түсіндірме?
we can explain,
Например, yeah, yeah.
we can explain on the.
Например.
Yes, we can take an example in extraction of gold from refractory gold-bearing ores. It's well known that currently we have very poor ores that contains a little amount of gold. And that's why we use, for example, as I have told in my presentation, the special developed fuming agents in order to extract this gold. And we use leaching process. And after that, we use this new foaming agent as a collector. And in comparison, for example, with another collector named T90, which is traditional foaming agent, our foaming agent can extract gold 1.5% better than the traditional one.
Okay, how about the answer? Mr. Johnny Aritonang, is there any follow-up question from you or enough? Mr. Johnny? Hello? Okay, maybe we can move another question also from Mr. Johnny Aritonang. He asks about the novelty of your novelty of your research. So you develop the new technique or method to ore beneficiation. How about the old technology? What is your novelty in your technologies?
Я концепции сказал. В каждом случае своя технология. Если новой не будет, тогда новой технологии не будет, с нами и зарубежные страны, и наши компании не работали бы. Естественно, есть новизна. Каждая работа, которую сегодня я и мои докторанты докладывали, во всех работах есть новизна. Без новизна работа не финансируется.
As we have told before, every project has its own conception, and that's why we first of all analyze if we can create new technology, we will create it, and after that we will implement it for enterprises, for foreign or domestic enterprises. But if we can use some old technology, of course we will use it, but with some extra modification or optimization, of course.
Без этого финансирования не может быть. Без
Without novelty, we can have a financial support from the government.
Если новизна отсутствует.
Okay,
that's why we always use create some novel projects.
Okay, for create some new novel project, also the your novelty. Okay, another question from the floor. Anyone? You can send your question directly. Anyone? You can raise your hand and also unmute your microphone. Oke, Bapak Ibu sekalian, apakah ada pertanyaan lagi?
Ya, Mbak.
Ya, siapa? Silakan.
Thank you.
Okay, Mr. Johnny Aritonang, please.
Okay, continue to my question. Thank you for explanation, but I want to see the reaction chemical. I mean, formula reaction, like maybe, for example, H2O tambah O2 jadi bla bla bla. So, I would like to see the reaction formula that you explained before. Thank you.
Okay, can you get the question, Professor?
Okay.
Can you please, how I understood, is the professor want to see the formula, the reaction of this process, yeah?
Yeah, chemical reaction of this process, like the combustion process, the hydrocarbon plus react with the air, produce hydrogen, and also produce the water and also the heat.
For,
Oh, but this process,
For
the
example,
chemical reaction.
yeah, and so thank you. For example, for project, every project has own process and own chemical reactions, own chemical activation, and that way also we have. But on our presentation, we didn't show our reaction because to show the reaction before this, we have thermodynamic countings, for example. For example, when you use the preliminary activation with bicarbonate sodium, for example, in my project about pyrite cinder, we have changed the phase composition, and we will see after preliminary composition will the our initial sample change the phase composition, and if we have after analysis we will see the our phase composition also will change, we will prove by the chemical reactions. It's also present in our project, but on this presentation we didn't show it.
Oke, thank you very much. Jadi Pak Aritonang, Pak Joni Aritonang, untuk penjelasan lebih lanjut, Bapak dan Ibu sekalian bisa melihat atau mengakses jurnal artikel di dalam jurnal kami. Silakan nanti diakses jurnal kami, nanti papernya, artikel dari Prof. Bagdaulet ini akan publish di jurnal kami. Oke, thank you very much. Mr. Aritonang, is there any follow-up question?
Біз фундаментальный исследование жасаған кезде реакцияларды жазамыз. В данном презентации мы уже результаты, конечные результаты подали вам, уже готовы к внедрению технологии. Вперед, жоқ, ол айтқанда
any chemical change in the process,
конечный технология. Ол айтқан жоқ қой, реакцияны көрсеткен жоқ. Фундаментальный жұмыс жасағанда бұл реакциялар болады. Біздің статьяларымызда, зарубежный журналдарда ол реакциялардың бәрі көрсетілді. А қазіргі жағдайда біз конечный результатын, разработанную технологияны презентовать етіп тұрмыз уже. Конечный результат. Не начальный, это фундаментальный, поисковый, потом фундаментальный, потом идет разработка. Это уже разработанные испытанные технологии.
When we are doing our fundamental research, we of course make these chemical reactions and activations and so on, and have all these reactions. We publish it in our articles and reports, but here we presented the ready to implement finished projects, and that's why we didn't show these reactions. If you need some more information, you can message us and we will send you this information.
Для предприятия, промышленных предприятий, интересует только конечный результат. Выгода, невыгода. Мы предлагаем выгодные технологии. Презентуем.
All enterprises are seeking only for profitability, and that's why we showed only the finished results without any reactions and fundamental searching.
Другой раз мы будем представить фундаментальные исследования, если желание будет. Другой раз.
Next time, professor says that we will show all fundamental research.
Там будет
with chemical reactions.
And also you can publish in our article in the next issue in the next year.
Yes, thank you.
Thank you very much. So next question from Fedi Setiawan. Greetings. Would like to inquire whether your research on bauxite purification technology is using the electrothermic process, acid process, or alkaline process. Which one do you use in the bauxite purification technology? Electrothermic, acid process, or alkaline process?
зависит от как кислотной или щелочной среда, это зависит от содержания как полезных элементов, так и состояния соединения алюминия. Какой продукт мы хотим получить?
It will depend on the initial composition of the sample and which kind of product we want to extract. And we can use both of them, but it will depend on this situation.
Основном выщелачивание щелочная, основном. Щелочно-содовое.
But in main ways that we use in our project is alkali.
Yeah. Ada alkaline process.
Yeah.
Okay, thank you very much. Maybe it also depend on the bonded other element in your sample, is that right? To choose the better method or technologies in urbanification.
Это зависит от выбора того или иного.
In determine the suitable technique.
Да. Зависит, какие элементы мы хотим получить оттуда, какие металлы, какие соединения.
It depends on which kind of elements or which kind of metals we want to extract from bauxite. It will depend of this situation.
В основном щелочная среда.
But the main way is alkali.
И композиция.
Alkali process and composition of the initial sample.
Okay, thank you very much for the answer. Yeah, another answer, Professor?
Технология, даже мы разрабатывали для Сколково, Россия, пигменты для кораблей.
Also, we developed the pigments for ships for Russia. It was our project.
Okay. How about the impurities? Did you also consider the impurities in determine your process? Other impurities in your sample that you said before, you consider the kind of the material that you want to extract. How about the impurities in the sample?
Учитываете, вредные вещества учитываете при...
Do you also consider?
Естественно, примеси, для того, чтобы чистые соединения получить, примеси обязательно учитываем. И для этого и фундаментальные исследования проводятся, что примес, он не должен войти, и мы должны отдельно отделить их, или, по крайней мере, он основному металлу, который мы, или соединению, которое мы хотим получить, она не должна мешать участвовать. Это мы обязательно учитываем. Но если у вас такой заинтересованность, ваше предприятие, мы можем отдельно обсудить этот вопрос.
Of course, we have to make to solve the problem. For example, we should solve how our extracted metals or elements should be pure. In that way, also we should solve this problem. But if you want to give us, for example, if you want to add the new project, we can discuss face to face.
Okay.
Also by financial supporting.
It depends on the supported financial supporting, is that right? Thank you very much, Professor. Mr. Fedi, is that okay, clear enough for you? Or any follow-up question? Mr. Fedi, okay, thank you very much. She said your answer is excellent. Okay, audience, is there any question from the audience? Maybe another question. Anyone? Is there any question from the floor? Okay. Oh, wait. Okay, because of the time and also Zuhur time, I'm sorry, we close the question and answer question. And also thank you very much for the answering the question, Professor, and also the team. The audience, this article will be published in our journal, Teknomekanik. You can access our open journal and make this article and other articles in our journal that related to your study as your references. And don't forget to subscribe our YouTube channel, as also stated in the flyer. Okay, Professor, can you see in the in the screen? This is your certificate. Yeah, this is your certificate.
Rahmet.
Thank you very much, Professor. It is our pleasure to have you here with us, Professor, and also for your team in contributing in this symposium and also in this journal. For our souvenir, we will send to you souvenir as we discussed in the WhatsApp. Thank you very much, Professor.
Құрметті ректор, құрметті бізді осы симпозиумға шақырған госпожа Кики.
Alhamdulillah. Thank you very much, Professor.
Сосын осыны ұйымдастырған Шухрилға бәріне көп рахмет. Сіздердің барлығыңызды өте қызықты болып өтті, жақсы ұйымдастырғансыздар. Енді егер жаңағыда айтылды, жаңа технологиялардың конечный результатыға да презентацияда көрсетілген. Егер сіздердің қызығушылықтарыңыз болса, біз бірге жұмыс істеуге дайынбыз. Рахмет көп.
On behalf of the Institute of Metallurgy and Ore Beneficiation, we would like to thank all organization team, Dr. Kiki, Professor Shakrik, and also Rector. Thank you very much. It was a very interesting symposium. And if you have some offers, we are open for collaboration. Thank you.
Thank you very much. Inshallah, we will send you batik, Indonesian clothes design to you and also to your students as our souvenir.
Thank you very much.
Thank you very much.
Inshallah, Professor.
Inshallah.
We wish that we have a collaboration with Universitas Negeri Padang and Satbayev University, such as student exchange, research collaboration, joint publication, PhD program for our lecturer. For your information, one of our managing editor of Teknomekanik Journal, Mr. Rahmat Aziz Nabawi, is very excited to have PhD in your university in industrial engineering. Maybe we will contact further contact to you, Professor. We hope we can keep in contact for more collaboration. Mr. Rahmat?
Yeah. Yes, of course.
Yes.
Mr. Rahmat will excited to have a PhD program in your university, in Satbayev University.
Yes, he's welcome.
Okay, thank you very much, Professor.
Rahmat.
Thank you.
Okay.
Thank you.
Welcome. We wish you health, prosperity, and also new creative achievement for the benefit of the development of science and industry in the Kazakhstan. We also would like, Professor and the team, we wish you health, prosperity, and the new creative to increase the study and also research development of science and industry in Kazakhstan.
ғылым дамытуға.
Thank you.
You're welcome. Okay, ladies and gentlemen, we also would like to appreciate all of the audiences for your active participation in this event. We apologize if there is any leaking today in our symposium. Hopefully, this symposium will be beneficial for everyone. Finally, it is end of our symposium. I am as your moderator, permit to end this symposium. Thank you all. See you next year. Wassalamualaikum warahmatullahi wabarakatuh. See you next year, Professor, and also the team. And also, ladies and gentlemen.
Thank you very much and stay safe, everyone.
Okay, for your information also, how about the next participant from Satbayev University? We open one symposium seminar international also maybe in January or February.
Айтады, келесіде тағы симпозиумға Сатбаев университетінен шақырамыз адамдар, қалай қарайсыздар дейді.
Жақсы.
Yes, Dr. Kiki, your idea is great. We are open to collaborate and work in the upcoming symposium. It was very interesting today for us also. Thank you very much for your effort. And also we wish you good luck and success in your upcoming activities.
Okay, thank you very much also from Universitas Negeri Padang. See you in the next year, all the audience. Wassalamualaikum warahmatullahi wabarakatuh. See you. Bye-bye.